Hello and welcome to part 1 of the number system, the language of maths. This video is relevant for any high school learner who wants to gain a better understanding of the subject. The number system is used to categorize and classify numbers so that there is a universal understanding of certain terms and definitions in the field of maths. This is useful to you as it will help you in sections of work like trig, inequalities, and the nature of roots. Without too much fuss, let's start delving into the good stuff. The number system is divided into the following categories of numbers: natural and whole numbers, integers, and rational, irrational, real, and non-real numbers. Firstly, here's the correct mathematical notation used for the number system. I suggest you pause the video if you need to take down notes. Good. Next, the properties of each type of number are pretty simple to understand. Natural numbers are those numbers that we would call counting numbers, as in 1, 2, 3, 4, 5. They are the numbers that we would literally find in nature, as in, look at those 5 cows. I really hope you would not say, look at those 4 3/4 cows. Whole numbers are the same as natural numbers, except that 0 is included in the set of whole numbers. An easy way to remember the difference between natural and whole numbers is by noticing that the word whole has O in it, which looks like the number 0. Integers are once again an extension of whole and natural numbers, but integers include negative numbers as well as positive numbers. Okay, the next category to look at is that of rational numbers. The definition, which you may be familiar with, is that a rational number is any number that can be written in the form a over b, where both a and b are integers and b does not equal 0. What this ultimately means is that a rational number can be written as a fraction, but the denominator, the number at the bottom of the fraction, cannot be 0 because that would make the number undefined or non-real. A simple rule to remember is this: if a decimal number is terminating or recurring, it can be expressed as a fraction, therefore it is rational. A terminating decimal is one that ends, no matter after how many numbers. So 5,5918274635278 is terminating because it ends after 14 decimal places. A recurring decimal is one that repeats the same pattern infinitely. So 0,636363636363, if it goes on forever, is recurring and can actually be expressed in fraction form as 7 over 11. In comparison, an irrational number cannot be expressed as a fraction because it is a non-terminating or non-recurring decimal. The famous example of this is the constant pi. The last two categories that we must look at is that of real and non-real numbers. Very simply, real numbers are those numbers that can be plotted on a number line, while non-real numbers can't. The constant pi can be plotted on a number line even though it is irrational, while the square root of -2 does not exist in the real number system and so must be considered imaginary or non-real. This applies to all square roots of negative numbers. Lastly, don't forget that each category of number in the number system is part of an infinite set of numbers. If you would like to see how these different types of numbers relate to each other in the number system, then please continue to part 2 of this tutorial video.
Created using Powtoon.